for at the end, maybe. Yeah, it was just a tease, sorry.
Oh, bummer.
Yeah,
I thought we were gonna do the whole slideshow.
I considered it, but I don't have any presentation software for the
It's
Coco
a
yet.
basking glow of the nuclear green.
Yeah.
Psychedelic.
Especially 420-ish.
Very happy we have had a successful vote down south. As of last night, we had about 70 people. A lot of the money we make is in the auction, and it looks like we've run out of almost of auction stuff. So I don't know what the financial.
People can grab this full of stuff.
So
Let me interject between you guys right now for momentarily.
All right, so I'll go ahead and start in the interest of time here. So for those of you who don't know me, my name is Brendan Donahue, and I guess you might say I'm the logic designer on the Coco VGA project. So, so yeah, we'll start out with a summary of this project and the goals here. Then we'll move on to status updates since last year, and then where we've been spending most of our time recently. So to review, this project is intended to target 6847 VDG-based systems. So that includes the Color Computers 1 and 2, MC10, Tano Dragon. This has nothing to do with the Coco 3. And the goal is to output VGA. So, so this project uses the 6847 digital IOs. So it only snoops the digital signals. It doesn't look at the analog signals at all to generate VGA. This project was started way back in 2011 by myself and my friend Steve Spiller, who lives in Washington State, with a perfboard prototype. And then in 2015, I asked Ed Snyder to give us a hand, and he provided us a mature prototype and production boards. So, so this is just again review. So this is the original perfboard prototype that Steve and I put together, and this is the prototype board that Ed put together. Notice it has dip switches on it for letting you do configuration and debug and things like that. A really nice board. And so since last year, so I fixed the long cycle modes, which are the RG2 and 3. Those are basically 16 address cycles per row of video. I fixed some video quality issues, added artifacts modes, some effects, and color palette controls. Ed completed the production board and the hardware button board, which we'll talk about here soon. I created a couple of disk extended color basic programs, a demo and a configuration utility. I set up a website with downloads, documentation, stuff you might need. But there is still stuff left to do, right? For example, at this point, I haven't really spent any time with the 6847 T1, which not only is it's a slightly different chip, but it also has different pinouts. So that's something that I need to visit, and then we need to, I'd like to support systems other than the Rev B board Coco 2. So right now, it fits a specific type of Coco 2. So they're reasonably common, so it's not the end of the world, but I'd like to hit some of these other machines. And then what about audio, right? So when you're using the TV output, your audio comes out through that RF jack. So if you're going to run VGA, how are you going to get audio out of your Coco, right? Are you going to continue to hook up a TV or ECR, or are you going to install a composite mod that has audio and video on it? So that's an unanswered question yet. Okay, so for those of you who haven't come by the booth, this is the production board.
Nice.
So yeah, it's a very nice board. Ed got this to me summer of last year. So probably the most obvious thing is that drops the dip switches. So here it is plugged into my Coco 2. So yeah, 6847, level shifters to convert from 5 volts down to 3.3, then the FPGA itself, 50 megahertz clock, the SPI flash that has the logic configuration in it. This is the header that goes out to the VGA connector, debug port, JTAG port for doing field upgrades. So second half of last year, I mostly spent time with video modes and other cleanup. So on the left, we have one Coco driving both a VGA and a composite monitor. So so you can see that the bottom monitor is kind of screwed up, assuming you can see it all the way from the back of the room, because this is a non-T1 part. It doesn't have the ability to drive, it doesn't comprehend lowercase. So you can see a mix of SG6 and lowercase there. So we have the optional reuse of SG6 for lowercase. That was actually a recommendation given to me by Art Flexer. But there's a couple different ways we can get lowercase enabled. So anyway, and then on the right, just a couple of games that rely pretty heavily on artifacting. Those pictures, kind of show the MES style artifacting mode that I lifted from MES, or I guess it's now called MAME, or been absorbed into MAME. So I think most of you are aware of these features. I'll just run through them real quick. So we can switch back and forth between the original and T1 character set lowercase. There's 5 artifact color modes, and swapping the artifact colors red and blue. Border color, there's 4 different ways you can set up your border. Scanline emulation, there's a video modes change status, so when you change video modes, it tells you, or you can turn that off. There's inverse video, you can configure the palette. You can get rid of the dark reverse video colors if you don't like those. You can disconnect the text palette from the semi-graphics palette, so you can independently control your text foreground and background. And then basically the full palette size is 512 colors, right? It's a 9-bit value, and so you can choose any of your 2 semi-graphics colors, your text colors, scanline color, reverse video color, up to 16 dithered artifacts colors using MES mode, and then last but not least, you can tweak your VGA timing. Okay, so I wanted all these features, but there's not really enough dip switches to control all this stuff, right? And even if there were, they'd be inside the case. You have to figure out how to expose them. So really, I want a software solution to controlling this thing. But the limitation is that the 6847 only has 5 addressable pins on it. Really, I mean, via the PIA, you can't. It's just an awful lot of stuff to program via 5 bits, a 5-bit interface. So, yeah, and then I guess to top it all off, those 5 pins affect what video looks like, right? I mean, they're the graphics mode, they're your alpha graphic setting, and your color set select. So you really can't be messing with those all the time anyway. So what you want is a way to program all this stuff, but do it in a way that doesn't disturb the video output. So, ideally we try to bit bang all this stuff in during the blanking region, but that could be a little bit tight. So I'd really prefer to have a frames time to program it, so let's see if we can figure out a way to get the 6847 to read its own register settings out of video memory. So here's time marching forward, blanking region 0, blanking region or video frame 1. So Coco VGA displays that. Blanking region n+1. We decided we want to do some register updates. So we've set up a block of RAM that has our register configuration in it that we want Coco VGA to consume. So what we'll do is we have a combo lock. Basically take those 5 pins that I mentioned, and we drive in a combination, one value after another, 5 different values, and then at that point, that unlocks Coco VGA and says, oh, the next video frame I'm gonna consume is register settings. I should display my old frame of video, consume the new frame of video that we're gonna now point the SAM over to read, and then at the end, we'll point the SAM back to the displayable video frame and we'll just pick up where we left off. So the idea was to basically hide the fact that this frame was going to read our register settings. So, pros and cons. So, pros, I have the ability to keep it from affecting the VGA video output. The cons, because we're switching to SAM, I can't affect, I'm negatively affecting the TV composite output. So you're gonna see a one frame flash of crap on the screen. On the upside, I've got a pseudo DMA of my register settings. Assuming you're running your process interrupt driven, right? So, you don't have to sit there and use the CPU to bit bang those 5 pins I mentioned to get all these register settings in there. Provides a high bandwidth gateway for current and other potential future enhancements. And we have a simple polling assembly language routine working right now. It's callable from BASIC, pretty straightforward. I'll talk about that here shortly. So the other downsides are, well, this doesn't really solve it for everything. It's really intended for, well, set it up and forget and run your legacy software, or new applications, right? And you're limited because I'm taking a frame's time to consume the registers. You have a limited register update rate, right? There's no way you can go faster than 60 times a second, and then you're going to keep it from displaying anything. So really, a 30th of a second. And there's no way to read, modify, write. So basically, you write into SRAM, you set your registers, and then that's it. So you can read, modify, write your RAM. So once you've set it once, you know what it is. But there's no way to read your configuration back out of the FPGA. So so as I mentioned, this is good for new software and set and forget legacy, but it's not really the end all be all. I'm gonna walk through it anyway because it's still kind of the major approach to this solution, or a major solution to this problem. But then I'll move on to another potential solution that we have thanks to Ed. So here are some example registers. I'm highlighting these in particular because they're the ones that I'm going to be manipulating in our example program here in a second. So the reset register, the one here on top, basically takes a bit mask as a byte, right, each bit. Lets you set, if those are set, then it basically resets those sets of Coco VGA registers back to their factory defaults. The edit mask basically tells us what banks or registers we want to update. So, in this example, we'll be updating the semi-graphics palette, so bit 3 there, so look for an 8. I've chosen in this example to replace the color orange with another color. So we're going to be manipulating offsets 48 and 49. So in 48, we've got the enable for this alternate palette register, and then we've got 3-bit red, 3-bit green, 3-bit blue. So I'll show that here in a second. Let's see. Okay, so this is kind of the who's who of the register interface and the way we're going to actually accomplish this. So in order of appearance, we kind of have to look for vsync. So we'll be using PIA 0 to handle our vsync flag. We need our SAM page select, in order to point to our alternate video page, and then to return us to the one that we want to play or want to display. And I guess I should mention that the page select is awfully fun to play with in general. You can put your Coco in PMode 3 or 4 and point to a page of BASIC, and you can see stuff getting updated and stuff like that. It's just kind of a cool graphical representation. But anyway, then PIA 1 to actually do our combination lock, right? Because it's got these AG, GM, and CSS pins. And last but not least, the memory map, which is at hex 400 is where we have the alpha semi-graphics page. I'm going to put the assembly language routine up at 6000, and I'm going to put my 512 byte Coco VGA register page up in page 56, which is at hex 7000 now. Keep in mind that it doesn't have to be a full 512 byte page. There's, you can basically just make it the size that you need in order to access the registries you want to update. Okay, so this is, I'll try to go through this quickly. So let's look at it from a standpoint of how we want to use it from BASIC. Thanks to Steve Spiller for helping me with this last summer. So we're going to start out by setting up our reserved region at 1600. We're going to load at line 20 there, load our machine language routine from disk, which I'll talk about in a minute. We'll set up a user-defined machine language call on line 30. Line 40, we pick out our pointer to the page of RAM we want to use for the registers. Then line 50, we're computing the integer value of this. We don't want a floating point value. We want a 16-bit integer to pass into the assembly language routine. And then basically this stuff here, 60 to 90, is setting up our page of registers in RAM. So basically we'll just iterate over our full page. Again, it wasn't fully necessary, but for this example, it makes it simple. And then we'll poke offset 0, which is to reset all our registers. Poke offset 1, which is our edit register, and we poked an 8 in here because we want to change the palette registers. And then we want to change orange over to blue. So we're going to hit the enable bit in 48 and put in a max value for blue in 49. And then we've basically set up all the registers that we wanted to set up. We call our machine language routine. It handles, in this case it's pulling, but it handles, waiting for the vsync and updating the register set. Okay, so I've got 2 slides on assembly. I'm sorry, this is an eye chart. So I'll go through it quick. The routine is generic. So other than returning us to a particular mode and a SAM page setting, but it could be even made more generic if we, say picked up the last value, saved our last values, or picked up the last SAM page from BASIC or something like that. So I've got some excerpts here. So we might, save off our condition codes and mask interrupts before we enter this. So this basically clear any pending vsync flag and then pull to wait for the vsync. And then the code segment down here, basically we're setting up the SAM. So it's kind of screwy in that there's basically a byte address, 2 byte addresses per bit. You write to, you end up having to write to different addresses depending on whether you want to set or clear bits. You have to check a bit and then decide, whether you want to set or clear that bit, and you just walk through the whole thing. So this code here from the bit A down to here gets repeated 7 times, once for every bit in the SAM. And then this is the code that programs the combination lock. Basically, it's a read, modify, write. So we'll read in, we'll mask off the bits that we want to change, or in our first combo lock value, write it back out. Mask off the bits we want to change, or in our new value, write it back out. So you basically do this, combo lock 1, 2, 3, 4, and boom, Coco VGA understands that the next page is going to read is register settings. Oh, and so, at the end of this, I guess, in this case it's polling. We just wait for the next vsync, and then after that we need to restore the PIA state. We need to put the video mode back to the way it was, and we need to point the SAM back to the page that we actually want to view. So anyway, so there's only 2 pieces of software today that use this. These are both extended color basic, and right now limited to 64K, but there's no reason we couldn't cut it down. So I have a mode demonstration, which is one of the ones that I posted to YouTube and Facebook, and then the configuration utility, which lets you do software configuration, and then it lets you save out your configuration, and then you can just rerun your configuration standalone from basic, say, before you run an application or something like that. Nothing for Nitrous 9 or anything like that, but you know, that's certainly within the realm of possibility. Okay, so now, what about legacy software? You know, where you want to change modes on the fly, or you want to, you know, plug in a cartridge and go. Well, you know, you can't run a piece of software before you do that to set up your mode. So Ed provided this this board for the purposes of you know, giving us a round DIN plug for VGA, a couple of debounce buttons for controlling FPGA, and you know, his intent was that it would be, you know, a five drill hole installation, as opposed to having to cut out a trapezoid for a D-sub connector. So yeah, he got this to me a couple weeks ago, and so this is very recent history, or very recent information. I think everybody's seen inside the Coco that I brought, so this is probably nothing new.
Good looking board.
Yeah, thank Ed for that. He did a great job. Okay, so what we've done for hardware mode control, I basically implemented some state machines in the FPGA that let us walk through different settings depending on what graphics mode we happen to be in. So there's a certain sequence that you cycle through depending on whether you're in text or semi-graphics, or one of the other high resolution graphics modes, or RG6. And this one's, you know, kind of special because it lets you switch back and forth your artifact colors and change your artifact color mode and things like that. The FPGA also recognizes press versus hold, so there's some features you can access by holding the buttons as opposed to pushing them momentarily. All this is documented on the website. Okay, so real quick, slight diversion. Where is... So this is a non-dithered 16 color mode that I just added yesterday and today. So anyway, it's using the you know, I'm limited to the addressing space that the 6847 can access. So this is using CG6 or RG6. It's a 6K video mode. So the resolution is limited to 128 by 96. But I don't know if it'll ever get used, but I thought I'd throw it in there just for the heck of it. So anyway, that's all I had. Are there any questions? Yeah, Boise.
So, with this mode here, 120 by 96, 16 color, is that, you know, there's the 256 by 192 mode. Do you think you can maybe push that in any direction with additional colors, or is that pretty much limited?
The 256 by 192. So that's actually the reason it is 128 by 96, right? Because it's 4 bits per pixel.
Yeah.
And so I had to divide each direction by 2, right, in order to achieve it. So I've thought about a couple of other things. You know, there is the possibility that I could potentially gang multiple frames together, buffer those, and then display those. I am at some point going to run out of RAM on my FPGA, so that would be the downside there. So, you know, I could probably implement that, but it might have tearing, for example. So I've thought about those. You know, I even thought about like a 256 color mode, but you know, the resolution would be pretty low. So yeah.
Still nice.
It's beautiful.
Thanks.
Yeah.
Anything else?
When is the projected time when this will be available for the public?
I don't know yet, but I hope it's soon. It's really once we start, once Ed starts making boards for us.
Do you know what the estimated street price would be of it, or is that too soon to tell?
I don't know yet, but I will say that, you know, Ed talked me into changing FPGA companies for the purposes of reducing price.
Okay.
So that is something we're considering.
And what company is that?
We're Altera now. I was Xilinx originally.
Very cool.
Any other questions?
It's amazing how much progress you've made since last year.
Oh, well, thanks.
It is awesome.
Thank you. All right, thanks everyone.
That is awesome. Thank you for sharing.
Yeah.
Thank you for supporting. Peter Kapinsky just stopped by and said hi.
Cool.
Michael Brandt, we just require a case mod for you.
If anybody wants to go to Micro Center, we're gonna be taking a ride over there.
Yeah, okay, I think that answer is yes, Mike, if you can hear me. I'll just answer.
Sure. So, I mean,
To do it right for the VGA header, right?
yeah, to do it right, yes. We can probably come up with a way without having to do it, but you gotta bring out a ribbon cable somewhere.
So if you wanted to do palette animation, you'd have to be doing a separate frame thing, would that
Exactly.
cause that flash like constantly then?
It does on the TVs, yeah. So if you wanna do palette cycling, so have you seen my demo? The
Briefly,
palette
I
cycling?
didn't look at it too closely.
So the palette cycling demo, yeah, if you watch it on the TV or composite monitor in my case, you'll see a flash every time it updates these registers.
Okay,
So, yeah, so, you know, it looks okay on the VGA monitor only because it's displaying the old frame, right? Because
yeah, just
I told
basically
it to.
uses it for extra frames.
Yeah, exactly. So, yeah, it's a bit of a trick.
Mind you, if you're using VGA, why would you be watching in the composite unless you're just demoing and you need something local to see it?
Exactly.
You're using VGA all the time.
Right. Well, and just like, you know, like the 16 color mode is not at all compatible, but, I mean, it's doubling the lines, so, you know, so, you know, instead of reading 32 addresses across, it's now reading 64 addresses across, so you'd end up with, you know, it would be wrapped, right? You'd have two lines on your, I haven't pulled it up lately on
On the composite side, yeah. That's really cool, actually. I like that.
Yeah, so I mean, I would love to see games that optionally exploit the features.